the bleeding stopped and then get smooth blood flow. So you can't have it keep going, going, going. You have to have checks and balances. That's why it does a job in low concentration. Think of it this way, its main job is when it's first being made in low concentrations. When too much of it gets out there in the circulation, then it does its secondary job. Okay? Remember, you want to localize that damaged vessel, repair it, then get the clot taken away and have smooth blood flow. These three minor systems have minor roles. Remember, the first three major systems make the clot, the vessels constrict, the platelets do platelet plug, then you have your clotting factors join it. Then the fibrinolytic system, the fourth system, breaks the clot down, gets the smooth blood flow going back. So what you have to know about the minor system, you've got to know you have three key enzymes. Kallikrein is the main one. Prekallikrein and we'll write about today. Filler. And then you got to know it's Fletcher. And you got to know it's Fitzgerald. RHMWK. Okay, so what you got to know about the minor system? Three pieces. You already know two of them. Prekallikrein, high molecular weight kininogen, and kallikrein. Kallikrein or kallikrein is the main enzyme of the minor system. And the two jobs are on the top. In low concentrations, they're going to help factor 12. They help the intrinsic system. Remember when I taught you on the contact? Remember when I taught you on the contact PowerPoint? What were the contact group? It was 1211 prekallikrein and high molecular weight kininogen. Okay, so think of it. They go together. Their main job in low concentrations when they're first being produced or they're first being activated is to help 12 become fully activated. They're going to help the intrinsic system do its job in forming the clot through that pathway. But when they build up and you get more, they say, oh, wait a minute, we got to stop this clotting right here. We're going to go say plasminogen, become plasmin. We need to keep that clot localized. So that's all you got to know about the kinin system. You know the three names, prekallikrein, high molecular weight kininogen, and kallikrein. And the job in low concentration is to help activate 12 more fully. And the job in high concentrations is to help, did I give you this, Jen, back there? To help, this is from my 1995 book, I like better than our book. Yes, I did. So, so if that helps you in high amounts to put high concentration, in low amounts to put low concentration, they're one and the same. That's all you got to know about that minor system for your test. I'm not going to test you anymore other than you got to know it's prekallikrein and kallikrein. Oh, and Jen, on 13, I forgot to change my answer key, so I'm just adding a point to everybody's grade. On 13, I'm not going to recollect them. Okay, so that's your first one, and that's basically what we've recapped. This is a big deal, the protease inhibitors. Where did you learn about protein CNS? When we talked about one of the groups of clotting factors, and I told you we'd get to that. We had the contact group, which had prekallikrein and high molecular weight kininogen. Now you know their role. We had another group that were vitamin K dependent on the clotting factor group. Remember what group that was called? That was the one you really got to know. They're called the prothrombin group. And there's 2, 7, 9, and 10. And 2 of the other things listed that are vitamin K dependent are protein C and S. So we'll discuss that a minute, what implications that means for a person if they're on Coumadin. Some of it's not good on another end. So these are, the big thing I want you to realize, these are natural. It's like your blood type. We're all born with the blood type we are. I'm A positive. I didn't have anything to do with that. My parents did, whatever they gave me is why I'm A positive. But inhibitors, these are inhibitors you are born with. They're not given to you as a blood product in blood bank. You naturally, if you're lucky, have these. This is the one I told you my daughter's girlfriend has, and she just had a PE. Just had a baby, and she's already had a pulmonary embolism, and she's 32. And she's already had 2 DVTs because she's deficient in protein C. All of us hopefully have these, or hopefully you'd already know because of a family member, or maybe if you did some kind of, if you did travel where you were sitting a long time on a long flight. That's where she first found out she had this deficiency, when she was on a long flight overseas. I'm gonna have you learn 4 of them in pairs because they work together. Antithrombin 3 is called AT3. And it works with heparin as its cofactor. Okay, these work together. All of us have a little heparin naturally, but in the real hospital setting, if you're having trouble with blood clots, they can actually give you more heparin to help you fight the blood clot. So that's one pair we'll talk about. And then the second pair is protein C and protein S. They work together. And you already know what alpha-2 antiplasm does, right? Because we said that was the main inhibitor of plasmin. We are naturally born with an inhibitor of plasmin. So that one you kind of have had to know for two different PowerPoints, okay? So how does because these 2 are very critical. In my era, if someone came in with a blood clot of unknown origin, and usually it's a young person, and they're thinking, why is a young person having a blood clot? I mean, what are they doing so wrong in their health that in their 20s they're already having DVTs? That's a big red flag that you're not older, overweight, have high blood pressure, or whatever, that's triggering maybe some bad health issues. So these naturally help your hemostasis be continuous, smooth blood flow. These help you to maintain that continuous, smooth blood flow. So how does antithrombin 3 and heparin work together? They, naturally the name antithrombin, that's going to be the main thing it attacks, which is 2A. But it'll also act on, the next thing would be 10, activated 10. But basically, so those are probably going to be your 2 biggies right off the bat. But basically, it can inhibit every factor but 7. So it's not just against 2A. It's not just against activated 10A. It can act on every factor by 7. So do you see why your ProTime would be longer to be elevated than your PTT? What's your main factor in the ProTime? 7. But all these other factors are in the extrinsic system, right? 10, 5, 2, 1. So it's ultimately, if you get put on heparin, it's going to affect your ProTime and your PTT. But since it doesn't act on 7, it's going to be slower to elevate it. And how do you know when something's acting on a system? It takes longer and longer to clot. The ProTime and PTT get elevated. So you got to remember this. It inhibits every factor but 7. And they work as a team. And we'll get more into detail when we talk about Coumadin and heparin. Because heck, if you wipe out and deplete your antithrombin 3, your heparin's not going to be effective. So they can't keep you on heparin indefinitely. Once your antithrombin 3 is used up, that heparin won't work. Okay, so we'll discuss that a little bit more in detail when we get to anticoagulation. Protein C and S help inhibit your 2 cofactors, 5 and 8. Remember, when you're diagramming your intrinsic and extrinsic, it's in the box. So remember, it was 9A, 8, calcium, PF3. That was the first box in the intrinsic system with the first cofactor. Then when it got to the common factors, it was 10A, 5, calcium, PF3. So the 2 cofactors have the 2 boxes. Well, these are 2 natural inhibitors to keep them in check. They're your main factors, and you have inhibitors that naturally help keep them in check. So think about this. I put you on Coumadin. Remember what it acts against? What vitamin? K. 2, 7, 9, and 10 need vitamin K to be made. And 7 has the shortest half-life. It needs to be made pretty rapidly, probably within a day. So it goes to try to make more, and there's no vitamin K, because what stopped it? Coumadin. Well, what else does Coumadin stop? Protein C and S. So you've got to be careful, because you're messing around with the inhibitors when you put someone on vitamin K, and they naturally help you stop clotting. So you're helping stop clotting by affecting 2, 7, 9, and 10. But these 2 inhibitors can't do their job when you're on long-term Coumadin. So that's a little check and balance. How much clotting can the Coumadin overcome? Yes?
I'm sorry, can you say that again? 2, 7, 9, and 10 vitamin K.
Remember, the prothrombin group was 2, 7, 9, and 10, and there was also protein C and S on there. So what happens, like what happened to my daughter's girlfriend that's missing protein C? What is she having problems with? Blood clots. Anytime she's on an airplane, long term. So you put them on Coumadin, protein C and S need vitamin K to be made. You're making them prone to clot because of messing up their protein C and S. So you have to decide, does it affect the actual clotting with 2, 7, 9, and 10 more? That'll inhibit clotting more on the factor way. So using anticoagulation is tricky, because heparin only works then when you give them an injection or a continuous IV, as long as they have enough antithrombin 3. And the more you put them on heparin, the more it uses the antithrombin 3 they have. So you can't just say, oh, it'll take care of it, throw them on Coumadin, throw them on heparin. You've got to think about what it does long term to your clotting factors, or in the case of Coumadin, to your inhibitors as well. And that's something we'll talk about as we get to it. That's not on the test. I'm just saying, coag's tricky, because you can't just say, oh, that'll just take it. Put them on that, it'll take care of it. It doesn't always. You got to think of the long-term effects of those medicines. So what you got to know from this one, what works together? Antithrombin 3 and heparin, and what do they inhibit? All factors but 7. Okay? Then what is another pair? Protein C and S. What do they inhibit? 5 and 8. And then what's your third one? Alpha-2 antiplasmin. And you already had to know that as an inhibitor for plasmin. So these are, if it helps you to write natural, you are born with them. You don't do anything to make you have them. Everybody is born with them unless they have a genetic deficiency from their family. Okay, so that's the second minor system. And the last one is complement. And what did we say already the main role of complement is? Immune system. And you're going to learn more about that when you get to the cascades in serology. But these are the only two I'll have you know for coag. They're activated by plasmin. It especially affects the immune system, but it has two pieces I'm going to have you know that help coag. There's a cascade Diane will teach you called C1 through C9. And when complement's activated, just like we have activated factors, when the clotting factors are activated, 7 to 7A, 9 to 9A, complement does two factors. C3 becomes C3A, C3B. C2 becomes C2A, C2B. C4 becomes C4A, C2B. So there's more than just an activated little A when you get to complement in serology. So one of them is called C5A that helps to aggregate platelets. And when we get to test methods, I'm going to teach you about a platelet aggregation test that the physician orders once you have a true bleeding time that's abnormal and you're not on aspirin. So you come and you're having trouble with petechiae and purpura and you're not on any medication, the next step after an elevated bleeding time or an elevated PFA 100, if the place you go has an automated analyzer, is platelet aggregation studies. And so there are lots of things that can cause platelet to join to platelet. Remember, aggregation is platelet on platelet. Adhesion is platelet on the damaged vessel, the collagen that's exposed by way of VWF. So anytime we're talking about platelet aggregation, it's platelet, 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 platelet joining to each other. And I'm going to teach you, there's a lot of ways to get that platelet to join to another platelet. And you can do them in vitro, adding different substances to make them clump together. And how they measure them is like a speck. They'll take a blue top, and we spin it really fast, and all the platelets are on the Buffy code, right? When we do a protem and PTT. You can do platelet aggregation studies where you spin it really slow. Where do you think the platelets are going to be? In the plasma. So it's going to be cloudy. You take off that plasma that has the platelets and you run it in a speck. Not much light is going to get through because it's cloudy. You add an aggregator, and there's probably 5 different aggregators they add to this plasma. As it makes the platelets clump together, they fall out of solution, and guess what happens to the plasma? It clears. So you put it in the speck, guess what? The percent transmission goes up because the aggregator caused the platelets to clump and fall out of solution, and it cleared it. So we'll talk about that when we get to test methods. The only specialty labs in coag that I know probably besides a Quest, like a reference lab, SLU has a big time special coag lab. Barnes has special coag. That's probably the 2 main ones on the St. Louis side. I'm not sure if SSM hospitals, they might have one hospital that does more special coag for them because they're a big corporation as well. So just know, that's all you got to know about complement. And I already had you know on the fibrinolysis PowerPoint, alpha-2 antiplasmin was the main inhibitor of plasmin, and the second one I put was C1 esterase inhibitor. So you don't have to know much from this PowerPoint. This is just to show you in a diagram how the minor system works. I'm not going to test you on this per se, other than, and it's already on your PowerPoint slide, which you have to know. But some people do better with pictures than words, so I really like the 1995 Harmony book, but for certain pieces that, never changes with coag. Okay, so those 3 PowerPoints will be in. I'm going to have to be gone on Wednesday. My daughter-in-law is having a procedure over at Barnes, that I need to be off for. So this is what I'm gonna do. I haven't used the testing center since it's been over in the LA building. And I'm gonna make the test, I'm gonna give you an hour instead of 50 minutes. I'm gonna put it in the testing center on Wednesday from 8:30 to 9:30. That way, you can get here and get over across the way to the new building, because it's in the LA building. And then I'll give you the full hour, but I want everybody, I'm trusting, but I'm not one of these that puts tests on Blackboard and everybody can take it at home on their own. I just am not there yet. And if anybody's gonna take my test, I want them taking it at the same time. I try to be trusting. Like I said, I probably shouldn't have given you your test back because Stephen hasn't taken it. But what happens is if I find anybody gives it to them, then there's no more tests going back. I'll keep them. So everybody thinks I'm crazy to give back tests. So I don't advertise it because I think it's very helpful to have your test to study from, especially for the BOC. So since '98, I've done it, and I haven't had it come back to bite me. And anybody they thought has cheated has done miserably on the BOC, so it takes care of itself. You cheat the program, they'll still get you. But, so you'll have from 8:30 to 9:30, and, because if we get through the D-dimer today, all we're gonna be down to is reviewing in lab. So we'll have done everything we have to have done. So that'll be the deal. I'm gonna find out all the ins and outs, but you guys have to call and make the appointment. But I'll give that to you on Tuesday, because I gotta give them the test Tuesday so they know what I'm talking about when all the students call and say, hey, I need to come in and take the test at 8:30. But that way you have time to get here, walk across to the LA building, take it, and you won't be rushed. Okay? So this is what we're gonna do today. That's another reason I tried to grab all the rulers I could. People who are by themselves, I'll make sure you have one, and the people who are together will share unless I don't if I have enough, but there's a lot of you by yourselves. Okay, here we go, here's another one. Okay. I was working on my calibration reference would not work that I used from last year. So we're gonna use the points. What I did is I did my patient and control using the points from last year, and my control and my patient worked. So we're gonna make the curve in here, and then we're just gonna run the patient and control over there. So it should work out really well. Here is your worksheet. I'll show you how our game plan. Pass those back. And this little fibrometer is fun. It's a little manual test. It takes a little manual dexterity because you got a pipette and hit the bar at the same time. But it's kind of fun. And I don't only have 2 MLAs and 2 Stagos. I can't have everything being done on those or we'd be here all day on a practical. So how I have it run, the practical, after today you'll know everything that's going to be on a practical. You're going to do a pro time and a PTT on the MLA 750. You're going to do a pro time and a PTT on the START 4. Then you're going to do the fibrometer for the fibrinogen, and then you're going to do the D-dimer as your test. That's like a serology kit test. That way we have more stations than just 4 for 6 people or 4 for 7 people. So there is a method to my madness. So what you're going to do, first thing we're going to do, we're going to break in groups of 3. So when we go to lab, we'll count off 4. Count off 3. This time I think I'll have it right. And group 1, group 2, group 3. And I was thinking, for the practical, you're going to have to draw blood too. So I was thinking, while the group's hanging out, you could draw the vacutainer for your practical. We could have that piece done. Then only have to draw blood if you want to. So, because what you're going to have to draw is a purple top and a blue top for the practical with a vacutainer on someone. Okay? So I'm thinking, since we really have 2 machines and a 3rd group, I think we'll do that. when you're not doing your machine, you'll try to draw. Then if you get it, then you got it done, okay? Because we're not gonna do the D-dimer until everybody's done. I wanna do that as one group, okay? So the first group is gonna go, I have it set up at Gen Station. It's a little machine. I'm gonna demonstrate to everybody, that way you'll kinda know what you're doing when you get there, okay? And I'm gonna monitor that system. So these are unique, and it's in your textbook. Your syllabus has the fibrometer procedure for running a patient in a control. So we'll put the page number on the board when we get over there. But the differences are, with fibrinogens, you make dilutions before you run your patient or your control. You do not run them straight. So that's the biggest mistake you can make, is not make your dilution. And you gotta pay attention which machine wants what dilution. They're different. So I would recommend on your sheet to write what dilution you're making, and we'll even write how to make it, so you have that in your head already. On the fibrometer, the control and the patient have to be run like each other. So they both get dilutions made. 1 to 10. I already have the reagents out on both sides. My start 4 that has the curve already built in is the one by Lorian and Tashawn's desk. So there's already a buffer called Owens buffer that you dilute your plasma. I don't care if you run your own plasma, but whatever plasma you run, I want you to run the same one on both machines. We want to see how they correlate, the results, okay? So how do you think I'd make a 1 to 10 using a control or a plasma? How much of what am I going to add?
1 and 9.
Okay, so we're going to do 9/10 of the buffer, and the buffer, I don't know if it's the person who discovered it, Owens buffer, and we're going to do how much then, if it's 1 to 9, then how much of the control or the patient plasma? 1/10, okay? And I don't care, and we're just going to do the normal control on both machines. So I don't care if we do multiple sets of pipettes at each station, because if there's 4 of you, you can have 2 people setting up their dilution. Everybody can get their dilutions made, and then you'll just wait your turn to run them. Okay? So I want you to stay with your group of 4, even if it takes us a little while to get through them. Because worst comes to worst, we'll do the D-dimer next Thursday. We're in no rush in lab. We are way ahead of the game. I didn't even get this far till I didn't even finish ProTimes and PTTs till this week with last year's group, and we only had 11 students. So we are doing awesome, okay? Then, on the start 4, the Stago, it calls for a 1 to 20. I put the procedure, there's one at the machine, and there's also one at the table where you're making your dilutions, okay? So no one should be wondering where a procedure is. They're right by the machine, okay? This time, the procedure calls for 1.9 to 0.1, but I don't like wasting that much reagent, so I cut it into half. So that's why when you see handwritten notes on the procedure, I didn't want to waste almost 2/10 of a mil every time you pipetted a tube. So I cut it in half, the 1.9, and that's 0.9 mils. And it has its own buffer. And then it's 0.05 of plasma or the control. So this is how you got to pay attention to what you put your pipetter on. Remember, it's been 2 or 4, So you gotta make sure you check that, who's ever leading your group. And then I did not pipette. When you're doing the fibrinogen test, you're measuring how much level 1 becomes the fibrin clot. So the reagent is 2A, it's thrombin. What they do is they bypass the whole cascade and they go right to giving you 2A to act on factor 1. They don't care about leading up to factor 1. They want to see how much factor 1 you have. So they give you the reagent that causes fibrinogen to become the fibrin clot. So your little vial on the start 4 is warming up. You're still going to have to put the pipette on and draw it up. Because I think that's good for you to have to do that with your group. Okay? So the reagent on the fibrometer, it's a little brown vial called thrombin. So they have the similar reagents, just I'm using Siemens reagents for the fibrometer, and I have Stago reagents, other than the control. I'm sharing, that's the only normal control I have. I'm sharing the control. Now, and I put the ranges, they're different for the different analyzers. I ran the fibrinogen yesterday. The control ran 250 for me, so I made the range 30 on either side. Okay? Then normal for both machines should be, all of us should fall between 200 and 400 milligrams per deciliter of factor 1. That won't change. The normal control was 330 for me when I ran it on the Start 4 yesterday. So we just made that normal control be 300 to 400. We'll see how it works. If we find we have to adjust for the practical, we will. When we have, 12 of us running it, more than just me running it by myself yesterday. And let's look at the procedure a minute on the fibrometer. So you see, the big difference where students make the mistake is not making their dilution. You gotta remember, you have to make your dilution on fibrinogen 54 maybe?
Yeah.
Okay. So don't worry, if all we get through is the 2 fibrinogen, yes.
I thought you said that there was different names for the buffers.
Different what?
There was different names for the buffer for each.
Well, this says STA Owens, this is, I don't know, just says Owens. They're both an Owens type buffer, but this bottle says like STA. But they're big vials, you'll see them. They're over by where you pipette. And so this is how you make your 1 to 20, and this is how you make your 1 to 10. So if it helps you to write on your worksheet up here, write yes.
Is this what the next step would be if you had like an elevated PTT to try to narrow
This
it down?
is the first factor assay they do after they make sure you're not on any medication. First thing is, are you on Coumadin or you're on heparin? That's the first question, and most of the time our elevations are due to anticoagulation. Then this is the first factor they go to because it's your main factor that becomes the fibrin clot. So if anybody's going to have a factor assay, this is an example of a factor assay. They're at least going to do the fibrinogen, and at least they can say the fibrinogen is normal, you've got to look at something else. Especially when both are elevated, it could be a common factor. Well, you've already eliminated 1 for them, they still could check out 2, 5, and 10. If it still wasn't, if their protype and PTT were still elevated. Okay. So make your 1 to 10. Then you're gonna put it in a test tube. Then I have an incubator. Our little fibrometer gets too hot. It doesn't stay at 37. So I have a little incubator that's at 37 set up right by it. Once you make your 1 to 10, so all 4 of your group can make the 1 to 10. Then you just got to take your turn. Then it's your turn. You're going to take that vial, which has 1 ml in it, and I have these cute little cups that go with the fibrometer. You take 2 tenths and 2 tenths. You set the timer for 2 minutes. And you can set up at the same time, they clock pretty fast. So once you just set up 2 cups, set the 2-minute timer. As soon as that timer goes off, I'll teach you, you go to the actual fibrometer, it has a well, you stick the cup in the well, and I have little vials of thrombin. You take your 1/10 pipette, I have a yellow pipette set at 100/0, and there's a little timer bar and the pipette. You hit them at the same time. So that's the trick, not missing the cup, because you gotta get the reagent in the cup and hit the timer, because that starts the seconds it takes to clot. Then we're gonna plot the points on the graph. You're gonna read it. So let's show you how you do this. This should be kind of familiar from hematology. Oh, I know, I wanted to give you this piece too. I'm gonna show you how you make the curve. Because you should understand how to make a curve. And this is exactly what we had to do, because we had the fibrometer. So this is an actual procedure of what we did at St. E's. And you're not going to get tested on how to make the curve. So you can put, I'm not testing you on this. But I think you understand what you're doing better if you understand the whole process. Okay. And this is what didn't work. We always had trouble. Look at this front page. What I did, I took that Owens buffer, and I had to use 1.6 mils in my tube that was 1 to 5. I made a tube that was 1 to 15. I had 0.8 mils of the buffer, and I had a tube that was 1 to 40 of 2.8. Then this is what I only had old stuff, and I can't get it anymore because the fibrometer is not in use in the real lab. Okay, so you take 4/10 of this one vial, and do you notice you don't do a serial dilution? How do you go to tubes 2 and 3? You go back to the original vial. Okay, so I had to take 4/10 of this. Well, I lied. You go back to the original tube. So I put 4/10 in my 1 to 5. Then I mixed that. Then I had to, for my tube 2, I had to take 4/10 and put it with an 8/10. And I had to go back to tube 1 and take 4/10 and put it in my 2.8. So in the end, I had 3 tubes. I had a 1 to 5, a 1 to 15, and a 1 to 40. So you make those tubes up right at the same time. Then they tell you to run them in duplicate on your machine. So I took my 1 to 5 tube, I mix it, put 2/10 in a little cup, 2/10 in a little cup, set my timer for 2 minutes. Ran those. And the value we got last year was the 4.7 seconds. So if you see your blank curve where we're going to plot in a minute, it was 4.7 seconds. Then I got those done. They matched within 5/10, just like ProTimes, they're going to match within 5/10. Then I took my 1 to 15 dilution, put 2/10, set my 2-minute timer. I ran them, and we got 13.4 seconds it took to clot. And they had to match within 5/10. Then we took the 1 to 40, 2/10, set your timer for 2 minutes. You ran them, and they ran 37.2 seconds. So, flip your page over. That gives you the seconds. So you're going to plot seconds on the y-axis, and on the bottom you're going to plot milligrams per deciliter, and it goes this way with the curve. So you're going to have seconds it took to clot on the y-axis, and milligrams per deciliter of factor 1 or fibrinogen on the bottom. So you're saying, well, how do you get how much factor 1 that you had? These reference come with the amount of fibrinogen in it on the bottle. So the example they gave you, well, let's use the one I have written down on the front of your graph. on my vial, it said there was 230 milligrams per deciliter of factor 1. And remember, normal is 200 to 400. Okay? So look at the formula that you have to do. I don't know who figures this stuff out. It just comes with the kit insert. This is the formula. If you turn your sheet over that I gave you with how to make the dilutions, this is how you figure out the points to plot. It'll vary by, so we got all these little vials of calibration reference that gave us how much fibrinogen was in it. It might be 230 this time, it might be 229 the next time. One vial was 217, one vial might be 260. You've got to use these little calculations to figure it out. So the first one, it says you take what it tells you on the bottle times 2. So if I took 230 times 2, do you see on the bottom of your page, that was 460. Okay, that's how I got the 460. So if it helps you somewhere on this sheet to say the vial was 230, that's how I started my calculations. Then it says on the 1 to 15, take the 460 divided by 3. So when I took 460 divided by 3, that was the 153. That's supposed to be, it's supposed to be a divided. See how, I don't know, those are dots. They don't look like dots. It's supposed to be dots. It's divided by 3. And then the last one is you take the original, in our case it was 230 divided by 4, and we came with 58. So that's how I got the points to plot. You don't know till you read your vial that you get from the kit. Like when the insert says 229, in our case, our vial said 230 last year. This example was 229. One year we had a vial that said 217. One year it was 258. You don't assume that every vial is 229. You got to read the vial that you order in from Dave. That was the company we got these from. So all I'm trying to show you, that's where these came from. I had to use that formula that comes with the kit insert. You're never wrong if you follow the kit insert, you guys. No one can say, well, how did you get that? I followed the kit insert. No one can say you're wrong. That's from the manufacturer. Okay? Now let's plot them. So I want everybody to plot their own points. You got them right in front of you. Your most difficult with graphs is figuring out how many each line measures. And I want to plot your own. I've got a copy of last year's. I copied. Everybody will have one to use that I made that's consistent for the practical. But I kind of want to see if you can plot your points and use yours today. I think that'll be a good experience to see if yours works. Okay, so the first point, what do we plot? These are seconds. We take 4.7 seconds. So how many lines is each single line? Oh, sorry, let me back it up. Okay, so you got to go up 7. And then how many milligrams do you plot it again? 460, and every single line between 400 and 500 is 10. So you got to try to, if it helps you to use your ruler and find and make a dot between 4, 7, and just make a single dot. Because everybody, I want you to use your own curve today, and I want to see how much your results vary before I give you what I copied for everybody. Because I have one for everybody. So everybody has the same. Then what do we plot the second point? 13. Now how many between 10 and 15 seconds? Every 2 is 1 second. So 13.4. And what milligrams are we going by?
153.
153. That's the tricky part. And between 152 to 200, it's every 2 lines is, every single line is 5 milligrams. Okay, and make your second line. And remember, if you mess up, don't worry. I have a curve copied. I just want you to see how to make the curve, even though we didn't get to actually physically do it.
So you went to
153. Down here. Remember, the milligrams are on the bottom, so you got to go across with the seconds and beat the milligrams. And I know it's tough on the eyes. And then the 140, you have 37 seconds. So 37 seconds, it's back to every single line. 35, 36, 37.2. And what's the milligrams?
58.
58. And there, every single line is 1.
I can't even tell which line is for 1.15.
Okay, so those are what my 3 lines look like. What can't you tell?
I can't tell which line is like for 115. Like it's
You're looking at the milligrams down here.
Oh.
You're not doing anything with those. You gotta look at the milligrams on the x-axis, you guys. You see how that's 460, that's 151, that's 155, so 153 is in there. 58 is right around here. You don't do anything with those.
Oh, that's all. It's confusing.
Nope. Okay, and you make, now these you want to do the best possible line. Start where you don't want to go dot to dot. So I'm going to go down by the 2 and put it in the corner of the 2 seconds. And you see, I've got 2 of them on the line, and my middle dilution is a little to the left. You don't go dot to dot. It's one single straight line the best you can. Now remember, I've got one copied that we're going to use for the practical, but I kind of want you to use your own today and just see how you did. So keep this and put your name on this one. That way we know it'll be the one you made today. And today's the 7th. The one I'm going to give you is from yesterday. And I'm going to put 47G. Okay. So Tashawn, start off. 1, 2,
3.
2.
Jen. Okay.
So 1,
1.
2, 3, 1, 2.
Okay, 1s are together, 2s are together, 3s are together. I think I did it right today. Okay, so what you're going to do, the 1s will be at the fibrometer, the 2s will be at the start 4, the 3s will be drawing with a Vacutainer, a blue and a Protyme. We're not going to worry if we get everybody done on the blood draw. It'll just be something to do instead of hanging out. And if it works, then you're done with your practical for blood drawing. So it'll be very beneficial if it works. I'm going to show everybody. Oh, and since we did really well running the PTTs as a whole group, how are we going to do the fibrometers? There's groups of 4, so you each have your own cuvette, right? So do not, when you're doing 1, 2, 3, 4 ID, you're going to do a normal control and your patient, whatever ID you give it. Like I did mine as 777. I have my results up on the Elmo. So then whoever goes first, you're 1 through 4. Then the next 5 through 8. Then the next 7 through 9 through 12. And then 13 through 16. We should only have to run 1 set of fibrinogens for 1 group. Okay? We won't worry about any repeats till the end. I don't want anybody to repeat.